Hello, I had this problem submitted by a grade 11 student, and we are required to determine tan of 180 plus theta and 3 sine theta minus 90 degrees. The diagram is what I've drawn. It was not part of the problem, and what we're given is that the cos of theta is negative 1 out of 3. Now cos of theta is x over r. Okay, that is the definition of the ratio when we are in standard form. So our x has to be the negative one. It assumes the negative value because r must be positive. So if we were to draw this, we would see that we have our x being negative. This automatically means we are lying where the point lies, where somewhere where it corresponds to the negative x-axis, so now our x is a negative 1, so it is placed there, and we have that our r is 3. We do not know what our y is just yet. How can we find y? If we find y, it will be easier to work out that tan there, the tan of 180 plus theta. So now we know that according to Pythagoras, y squared is equals to r squared minus x squared. Okay, and this will be 3 squared subtract minus 1, and we square it, so this is 9 subtract 1, so our y squared is an 8, meaning that y is plus or minus the square root of 8. We can write the square root of 8 in this form. We can call it 4 multiplied by 2. Okay, and we know that if it's a product under the square root sign, you can take a square root of each one of these. Okay, so basically we have square root of 4 multiplied by square root of 2. If you're confused with this, look up the work on exponents. So now this is plus or minus 2, the square root of 2, and this is a set form for our y. So now we've got all three properties. We've got our x as a negative 1, we've got our y as 2 square root of 2, so this is negative 1, the point there is to negative 1, and 2 square root of 2. In the answer generated, y can be either negative or positive. You'll see that this depends on in which quadrant we lie, whether y is positive or negative in that quadrant. So with the first problem, we are asked to determine the tan of 180 degrees plus theta. What is theta? Well, theta is where our solid line, the angle made by our solid line with the positive x-axis, because we measure our angles from the positive x-axis. So that is theta. Okay, now they're asking us to determine the tan of a function of an angle that is 180 plus that theta. So we've got our theta measured from the positive x-axis, but we must rotate further another 180. So when we're sitting here, the angle made, that angle above, the angle made is 180 degrees plus theta. So we find ourselves here after making that rotation. Okay, but what would be the coordinates here? The length of the line hasn't changed, so it's still 3. R is 3. And what happens to our x and our y? The y here would be negative 2 square root of 2, and the x there will be 1. So when you rotate this line, you make any type of rotation with the line, your respective xy values remain, and the 3 which corresponds to r also remains the same. So the point here, the point there, which also is a rotation of the same line that started off as a line of length 3, rotated an angle theta, the distance from the center doesn't change, you see. So the length of that line is the same. We're rotating the same line. Okay? Knowing that now our x here is 1 and our y is -2 square root of 2, and knowing our r is 3, can we just determine the tan of this? Tan is y over x. So now our y is -2, the square root of 2. Our x is 1. So we've got our answer. -2 square root of 2. Can you see why tan is negative? Well, let's think back to cast. The cast rule. There we go. So in this quadrant, which is the fourth quadrant, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Now in the fourth quadrant, we know that cos is positive, so tan comes out negative, and we're not surprised. Okay. 1.2, what are we required to determine? We're required to determine 3, the sine of theta minus 90 degrees. How can we find the xy coordinates and the r for this? Well, we started off with this line. Okay, we started off with this line, and on this line, what we need to do to achieve this rotation is we need to move it backwards. We need to rotate it 90 degrees backwards. Let me use a different color just for. So now we're rotating it backwards 90 degrees. Okay, so we go theta that way, but then we go back 90 degrees to achieve this here point. And at this point, our x will lie over there and our y will lie somewhere there. So now the coordinates for this new point is, the x coordinate is 2 square root of 2, and the y coordinate is 1. Do you see how they have swapped from what they initially were? I mean, ignoring the sign. Of course the sign changed. In this quadrant, which is the first quadrant, both coordinates are positive, but what used to be our x value is now our y value, and what used to be our y value is now our x value. So always think of this when you're doing 90 rotations. You'll see that there's this tendency for these values to swap on a 90 rotation of a line. Okay, and this is clear when you do reduction formulae for 90 plus, 90 degree plus, and 90 degree minus, 270 plus, 270 degree minus theta. Okay, now we are sitting here. Our angle now, this angle, we can say is theta subtract 90 degrees. Can we do the sine then? If we are sitting there, we need to evaluate 3, the sine of, well, I don't know why I'm writing that over, that was not necessary, but yeah, 90. And we just need our, we have 3, and we need to evaluate our sine function from there, multiply. So it's y divided by r. That is the ratio for our sine angle. So now we're multiplying 3 by, what is the value of our y? It is 2. Ooh, okay. Are we making mistakes now? All right, there. No mistakes. Let's keep the focus. So our y value is a 1. That is our y coordinate. Our 1. Okay. And the r is 3. 1 out of 3. And both of them are positive, since this angle lies in the first quadrant. Okay. Of course, that is a 1. And that problem is solved. We will look next at a simplifying problem. From the same students, we've got a simplifying problem. Let's look at that. Okay, I didn't want to bore you with all the erasing and stuff like that. I still struggle a little bit with that, so it's quite slow, but yeah, this is the simplifying problem submitted by the same student. Now we are required to simplify sine negative 210 degrees divided by cos 300 degrees added to cos x plus 90 degrees divided by sine 360 plus x. Okay, how can we approach this? We see this requires the skill of working with negative angles. We also see that the understanding of the reduction formulae is required here, since we have all these 360 plus an angle plus 90. Okay, so yeah, let me start in one direction. There's a couple of ways to do it, but one of the ways in which you can simplify this is that you can look at 360. Let's remember 360 is just 0 degrees really, minus 210 degrees, and I could divide that by the cos of 300. How would I want to look at 300 in that scenario? Well, one can look at 300 as 360 subtract 60. Is that 300 degrees? I think that is 300 degrees. Okay, now we have on the other side the cos of an angle x added to 90 degrees. In this scenario, you need to be able to use the reduction formulae to simplify this. I would prefer to write it as negative okay, I got myself a bit confused. I saw that something was amiss there. The problem is this is not a plus, this is a minus. Okay, and so we have x minus 90 degrees, and I wanted to simplify this in this fashion to have the negative of 90 minus x. Can you see how this, the angle in here is the same as this? The negative sign multiplies in, you have negative 90 degrees, and you have plus x. Okay, so we can divide that by sine 360 plus x. How would we like to think of that? I would like to simplify that simply by calling 360 degrees, calling it 0. And you could just put sine of x, of course. I'm just doing this to be very verbose and very, hopefully, explicit and clear in being verbose. Okay, now what we need to do is subtract 210 from 360, and that gives us 150. Can we check that? That is a 360 years. So, and we divide that by, what do we do? This is a 0, isn't it? The cos of negative 60, is that what we're looking at? Because, I mean, we said we had 300, we wanted to call it 360, subtract 60, because that is 300, but that is just the cos of negative 60. Okay, and what happens here? What happens when you got the cos? But okay, let's start by taking the negative sign out, perhaps. And why can you take the negative sign out like this? I want you to think on that. Why are we able to take the negative sign out of the cos function? I want you to think about it even as you start to draw your trig functions. So as you draw your cos function, what happens when the angle is negative? Does it make a change to the cos function when the angle is negative? Does it not? I want you to think about that. We will talk about it as we do more work. Okay, let's simplify this now. Let's make our lives easier and just call that the sine of x and stop beating about the bush with it already. Okay, how can we write sine of 150? An alternative way of writing it will of course be sine of 180 degrees minus 30 degrees. And then can we take the negative sign out of cos and have it as cos 60 like that? Okay, and we subtracting now because of this minus sign here. The cos of 90 minus. Should I explain that a little bit? Maybe let's look at that, the detail there. If I have an angle at 90 minus, and it corresponds to what was the angle here. This is a very small sketch. I hate it. I'm not gonna explain on such a small sketch, no. Okay, let me draw this a little bit bigger. What I'm trying to explain is this. So if I have an acute angle here, theta, and of course if I'm to add 90 to it, it will lie somewhere there, and this would be the angle theta, and this is theta at 90. This is 90 plus theta, if this is the angle. So now we would have to, if we have some x value, let's call it x1, and some y value, let's call it y1. What happens when I rotate when I rotate a total of 90 degrees plus theta? Well, what happens is that what used to be my y value now becomes my x value, and what used to be my x value becomes my y value, only that the y value is negative. Can you see why that happens? So that is why we have negative. So now we do cos 90 minus theta. We work with 90 minus theta, and it's nothing I can do for now. So let me think on it.